Okay, today we are going to do how to solve a trig equation. And you did it all last unit, just a carry on of what you did. Okay, so last unit we talked about this from grade 11. Okay, step 1 is your algebra. So we talked about one variable, you can isolate. We talked about two variables. What's your first thing every time if you see two variables? Before factoring. Equals 0, then you can look for factoring. If it's not factorable, formula. Okay, then when you do all that algebra, it gets you what we call a what over here? Trig value. Okay, that is not your answer. You're looking for the angle. So you can do two things. You could first ask yourself about the trig value. Can it be found on a unit circle? If it can't be on a unit circle, you have to do what button? Inverse. And you have to do all your analysis stuff. So what quadrant are you in? Inverse it. Final answer. Okay, we're going to do all that. We're going to add one layer to the start of it though. Okay, but all that other stuff should be familiar. So you got that with you. Okay, here we go. The layer we're going to add is the very first step. So we have a sine theta and we have a sine of a double angle. Those are not the same thing. We can't figure out the angle part when we have an angle and a double angle. So what we're going to do is we're going to take an identity and we're going to make a substitution. Okay, so this is the layer that we're adding. Can you go to your formula sheet? The double angle corner is here. So sine of the double angle, is there a formula to replace it with? Yep. 2 sine cos, so 2 sine theta cos theta. Okay. That's it. That's the new piece. Now all the stuff is grade 11 and then our last unit. So here's my question. How many variables do you see? 1 or 2? Bless you, bless you. I see 2 variables. So boom, what are you doing? Equals 0. So we need that to happen. So I moved that over. That's what I did there. Do you see it?
Why can't we divide it all by sine theta?
Okay, so here is why. Okay, so this is how I properly do it. Okay, so GCF, right? Does that look familiar? Good with that method, right? That was what we did. So you're saying this to me. Why can't I just divide by x? So if I divide by x, I get x equals 2. Did we get to the same answer? No. Okay, so when you do this division part, you eliminate one of the answers. Yeah. Does that kind of help you compare? Yeah. Okay. So when you have 2 variables, you have to have it equal 0. Okay, so what kind of algebra do we want here? So we talked about, we were on this side, we were equal 0. So my first brain checklist is, does it factor? One of the styles. That's what you're looking for. Is it anything you know? Yes, I think I heard a whisper. GCF? Is that Will? Was that you whispering? Okay, there's this term, and they both have sine theta to take out. Good? You see it? Okay, here we go. Sine theta times what makes that? Sine theta times what makes that? Sine theta equals 0 on that multiplier. And cos theta equals 1/2 on that multiplier. Okay, that's the algebra portion. And so remember, we did all of our algebra and we just got to a trig value. So now we go into what do we do with angles. So my first question would be, do we see things from a unit circle perspective? And the answer to it is yes and yes. So I'm actually not even going to touch my calculator. Okay, this could be on your exam without the calculator then. Okay, so where does sine theta equal 0? So I'm looking for where are their heights of 0? Height, a y value of 0. So I found some spots where it's going to work. Let's go back to the top here. It tells me about theta. Well, first of all, is this showing me I should be in degree or radian language? So that's what you need to talk about. So degrees. So 0 degrees is an answer. 180 degrees is an answer. 360 could have been an answer, but it's not. Did I catch anybody writing it down? Why is it not an answer? That says I have to be less than 360. I can't be equal to 360. Okay? Otherwise, I would have answered it on another question, but not this one. Okay, so now we have a cos to deal with. Cos is 1/2, so I'm looking for x values. I'm looking for x values of 1/2. So I found spots on my unit circle. X value of 1/2, so I can go 60 degrees and 300. Okay, question 2. So this equation has sine squareds and coses. That's a whole mix of stuff going on. Okay, so I need to make a replacement. What am I replacing? Should I find something for sine squared or should I find something for cos? So there is nothing to replace cos with. That's the lowest you can go. So I'm looking on my formula sheet. Sine squared. Do you see any info about sine squared? Okay, so here's the top corner. Sine squared. How can you maneuver this formula? to be sine squared equals, what would you do? You'd have to minus that over, right? Does that make sense? I'm using this line, but I want just the sine squared. Okay, so I moved that over. So this is my replacement for sine squared right here. You good? That's what we're doing. We're going to go 1 subtract cos squared. So that's the only new piece of info, and all the rest of the stuff you know how to do. Just making a substitution from this paper. Okay, algebra time. My first maneuver would be get rid of the brackets, distribute that. Actually, that's where I find that most people make mistakes on their test, is just that. Distributing a bracket. Okay, are you with me here when I say there's two variables? I can see my trinomial and I'm going to be 0 on one side, right? Do you see all that in your head already? Trinomial 0. Are you okay if I go this way? Because I hate negative squareds. I hate them. I don't want to factor with a negative squared. Okay, so this part is actually where I find all the mistakes on people's tests, in the distribution and the movement. So that's just, make sure you're careful with your algebra. Okay, I'm going to try to factor. It is a complex, but I don't really have that many options here, so I'm going to play around. So I put 3 cos and 1 cos to make my f. And to make L, you need a 1 times a 3. Do you want to play around with where you would put a 1 and a 3? And remember, here's my swivels. That's got to make an 8 at the end of it. So where would you put a 1 and a 3? So I did this way because I saw that this loop could make a 9 and a 1. I could see that ahead. So plus 9 minus 1. So just check, does your FOIL work? First times first, good. Outside 9 cos minus 1 cos is 8, check. Last, check. Okay? Do that more often, because you shouldn't be making mistakes factoring, because you can always FOIL it to check. Okay, boom, we got our trig values. Okay, you're not even half done. Okay, so now we're going to go into the angle part. I'm going to answer this one first. Takes me 2 seconds to answer this one. No solution. Cos, that's outside of the cos zone. Okay, I'm going to go to this one. My first thought was, do I see a 1/3 on a unit circle? No. Second thought, Astica, where is this angle? Cos positive. So So I'm in quadrants 1 and 4. Then I grab my calculator because I'm going to have to inverse stuff. Uh-oh. Calculator's not turning on. Do these things ever die? Okay, let's talk about this part of the question. Radians. So when I grab it, we got to be in a radian mode. Radians, cos inverse a third. That's the reference, but it is also just this answer. Q1 always has the same as a reference. And here I'm doing what to get this location? 2 pi minus. So 2 pi minus that reference gets me 5.052. That makes sense. Remembering that quadrant, there's 4.7 here, 6.28 there, so that makes a good number. Makes sense. Okay, last question. Okay, so in this question, I got tan squareds and I have secants. So we replace, we can't have two different languages going on. And I'm always picking squareds on these ones. And why am I always picking squareds? Because this corner, that's all it has is squareds. Okay, so I want something for tan squared. So if you want this on your paper, how would you get tan squared? So you'd have to move this over. So secant squared minus 1, right? So that's the tan squared value. Okay, there's your replacement then. Secant squared okay, that is the only new thing you're learning today, is that replacement. Okay, now I put the 2 in front of it, right? Don't forget that that's 2 times that replacement. Distribute. You're going to zero this out. It's going to be a trinomial. The last times the last, where are you going to put it? You have to have a 1 times the 2 at the end. So be careful at your placement now. Here's where you really dive into your placement foils. Where are you going to put a 1 times a 2? You put them in the right spots to make a -4 plus 3. Okay, so these are the trig values that we came out with our algebra. We're good there with the factoring. Okay, so we don't work in secants. So we have to change our language to which flip? Cos, so cos equals -2 when I flip that. And cos equals 1/2 when I flip that. So there's my flip trigs. I'm going to answer this one first because it's a 1-second answer. No solution for cos outside that one zone. And then here, first of all, yep, I recognize it on the unit circle, so I'm not going to touch my calculator. I'm looking for x values of 1/2 to answer with. So here I am at 60 degrees to 300 degrees. But let's talk about the answer here. I said to answer all values. That's what it says. So I'm going to actually write in radians. So I'm going to go pi over 3. But I have to say every single answer ever. So what do? Plus 2 pi k kei. So that includes every revolution of that location.